Hello guys, how are you today? So today I'll be explaining the questions only in the chapter 7 notes. It's only 4 pages, not a lot of questions. It's actually really easy. Okay, so we start on with exercise 1. The element copper has two naturally occurring isotopes of mass numbers 63 and 65. The relative abundance are 69.2% and 30.8% respectively. They need us to calculate the average atomic mass of copper. Okay, so to calculate the average atomic mass, we're gonna do the sum. This is a sigma notation. Please, you can laugh. Okay, it's fine, but don't make it a big deal. A sigma notation. This means the sum of what? Of the mass numbers of the isotope. So I'm just gonna say mass number times the abundance. But the abundance should be what? Over 100 because it is percentage. So in this case, we're going to do the sum of the mass number times abundance. So it's going to be 63 times its respective abundance, which is 69.2 over 100. Then we are going to add it to 65 multiplied by its respective abundance, which is 30.8 over 100. So if you do it on your calculator, 63 times 69.2 over 100 plus 65 times 30.8 over 100, you are gonna get an answer of approximately 63.616. So let us round it to approximately 63.6 grams, I believe. Okay, so the average atomic mass is gonna be 6 grams. So we move on to CQD number 4. Okay, so here they told us to write the electronic configuration of the following atoms. So of course, we are on the answer key, it is written what? To use the SPDF rule. The SPDF rule is not coming for us unless you want to use it. So it's gonna be this is a method that I use. It's like SS. Then SP, then it's gonna be DP, SDP, and then SFDP. So if you want to use the SPDF method, you're gonna have to memorize it like this, okay? So this is 1, 2, 3, 4, 5, 6, 7, 8, and whatever. Or you could do it the way that I explained it in my notes, which is like this. You write S, SP, SPD, SPDF, and then you are gonna draw some arrows. So it's gonna be like S, then S again, okay, then PS, then PS again, then DP, then D. So you're just gonna draw the arrows multiple times, okay, until you reach okay, this is gonna be 1, 2, 3, 4, then 2, 3, 4, then 3, 4. So you're gonna start with 1S, then 2S, then 2P, then 3S, then 3P, then 4S, then 3D, then 4P, and etc. Of course, I know this method is a bit confusing because it is required, but at the same time, it's not necessary to put it. So I would prefer if you use the digits instead. So CQD number 4, write the electronic configuration for the following atoms. 11Na, it's gonna be 2, then 8, then 1. This is for 11Na. For 15P, okay, it's gonna be 2, then 8, then 5. Okay, for 19K, it's gonna be 2, then 8, then another 8, and then 1. Okay, same for CQD number 7 grid. They need the electronic configuration for Li, so it's gonna be 2, then 1. For P15, it's gonna be 2, then 8, then 5 again. Then for CQD 8 grid, they need the electronic configuration of the following atom. So I don't know why they said that the sentence is all wrong. Write the electronic configuration of the following atoms using 288 electronic configuration. Okay? So just in general, the way they're asking the questions in the CQD is incorrect and the answers in the answers is wrong. So you're not gonna be using it. You're gonna be using this method if you want it to be easier. Of course, you can use the SPDF method, but you have to just memorize it based on how it is. But if you use the SPDF method, there's going to be some tricks that we did not learn of yet. That's why it's not recommended for you to use the SPDF method. Instead, use the electronic configuration. So for 11 and A, okay, it's going to be 2, then 8, then 1. This is for 11 and A. And then for 8O, it's going to be 2, then 6. Okay, so we move on to exercise number 2. What is special about the electronic configuration of noble or inert gases? Noble and inert gases have an electronic configuration in where they have 8 valence electrons. Okay, and that means they are inert. They will not react with anything. So they told us in part B, is this the electronic configuration of a noble gas 287? It's not. Why? Because if you look at the last shell, it has 7 valence electrons, whereas if it's supposed to be a noble gas, it is 8 valence electrons. Okay, we move on to exercise number 3. They told us fill in the table below. So Li, it's gonna be 2, then 1. So it is in period 2. Now, how do we know the period? You're gonna count how many numbers did you put. So you have 1, 2, 3 numbers. That means it is in period 3. And if you want to check the number of valence electrons, you look at the last shell. It's 1 valence electron, and the group is also the last shell, which is 1. So for Li, it's gonna be 2, 1. It's gonna be in period 2 because you have 2 numbers. Okay. And it has 1 valence electron, and it is in group 1. Same thing for K. It's gonna be 2, 8, 8, 1. It is in period 4 because it has 4 number or 4 like blocks. Then it has 1 valence electron, and it is in group 1. We also move on to 15. Okay, so it is gonna be 2, then 8, then 5. So for P15, it's 2, 8, 5. Again, it has 3 numbers, so it's gonna be in period 3. If you look at the periodic table and you look for phosphorus 15, you're gonna see it's in the 3rd row, which is the period. Then it has 5 valence electrons, and it's in group 5. Okay, and then finally for the argon, it's gonna be 2, 8, 8. It's a noble gas because it has 8 valence electrons. So then it's gonna be in period 3. So if you look, it's in row 3. It's gonna have 8 valence electrons, and it is in group number 8. So we move on to CQD number 5. Again, they want us to write the electronic configuration of the following ions. Now, what's the difference between an atom and an ion? An ion will either lose or gain electrons, so it will have the electric configuration of a noble gas. So 8O minus 2. Originally, oxygen, it has an electronic configuration of 2 and 6. But if it's gaining 2 electrons, then you are gonna add 2 electrons to the valence shell, and it's gonna be 2, 8. And as you notice, it has 8 in the valence electron, so it has the configuration of a noble gas. Same thing is for the Na+. So Na+ originally is 2, 8, 1. So if you remove 1 electron from it, it's gonna become 2, 8. So it has the electronic configuration of what? Of a noble gas. For Mg2+, it's the same, and G2+ is usually 2. I should stop writing it like that. 2, 8, 2. Okay, and then, so it's gonna lose 2 electrons because it's plus 2. Okay, plus 2 means it lost 2 electrons, and so it's gonna have an electronic configuration of 2, 8. Now, for N, it's originally 2, 5, but then it will gain 3 electrons, so it becomes 2, 8. So that's pretty much it. So if you're writing the electronic configuration of the ions, it's going to be 2, 8, 2, 8, 2, 8, and 2, 8. Okay? Now, they told us use the periodic table to write the formula of the given compound or ions. What you should do is we're going to open the periodic table. So I'm going to split screen. Okay, so here we have the periodic table, and we are looking for barium oxide. First of all, we know that barium is, we need to find barium first of all. So barium is over here. It is in this group, this column, and this column always has 2+ charge. Okay? Oxide is oxygen. It's in this column, so it always has 2- charge. So when we are looking for barium oxide, then we are talking about BaO. However, if we're talking about boron oxide, boron is here, so it has a charge of +3, and oxygen is over here, so it has a charge of -2. So it's gonna be B3 plus O2 minus. You're gonna apply the crisscross method, and you're gonna get B2O3. So over here, it is B2O3. Okay. So now we're dealing with aluminium fluoride. So aluminium over here, it has a charge of 3 plus. Let me just change the color. Aluminium has a charge of 3 plus. Fluoride has a charge of 1 minus or -1. So it is Al 3 plus and then F minus. You do the crisscross method, you're gonna get AlF3. So aluminium fluoride is AlF3. Sodium sulfide. I think I'm just gonna clear the screen. So the first three are finished. We moved on to sodium sulfide. Okay, I wonder why these elements are highlighted. Oh my goodness, that's so cool. Wait, look. So if you go to hydrogen, as you can see, hydrogen has one valence electron. I can't circle it because it's moving, but as you can see, there's one valence electron on the shell. So for example, if you go also to, let us say, boron. Boron is supposed to have 3 valence electrons. So on the last shell, it has 3 valence electrons. But if you go, for example, to argon, which is a noble gas, you will see that on the last shell, it has 1, 2, 3, 4, 5, 6, and 7, 8 electrons. And this is really cool. So if you guys want to use this, I just searched it on Google and I got this. So you can use it to understand really what is happening and what do the electrons look like and whatever. I want to see what 103 probably looks like. See how cool this is? Chemistry is so cool, guys. Okay, I stopped the video for a bit, but just look how awesome this is. I'm mesmerized. Okay, anyways, back to where we were. So sodium is Na, it's gonna have +1 charge, and sulfide. Okay, and sulfide is sulfur over here, so it has it's 2 minus. So it's gonna be Na plus S2 minus, do the crisscross method, and it's gonna be Na2S. So over here, this is Na2S. Calcium nitride is gonna be Ca, so +2, and nitride is -3, so it's gonna be Ca +2 or 2 plus. And then N3 minus, you do the crisscross method, you're gonna get Ca3 N2. So over here it's Ca3 N2. Okay, then we have potassium oxide. Potassium is K, so +1. Oxide is also -2. So K plus O2 minus, you do the crisscross method, so K2O. Okay, now the chloride ion. Okay, now the chloride ion, we can come over here. We will see that Cl is gonna be minus, so it's Cl minus. Now I believe you guys can do the rest by yourself, so I'm gonna leave you guys to do it by yourself. Okay, so I'm gonna let anyone answer. Nobody's answering. Okay, you guys can't answer. I know, I'm just kidding. So I'm just gonna write the answers. Okay, I will pause the video, write the answers, and let you guys see it. So these are the answer keys. Hopefully you guys got them all correct. And that is pretty much it for this one over here. Okay, so we move on to CQD number 15. So they gave us these three figures. They said, A, give the reason why particle C is a negative ion. It is a negative ion because, as you can see, how many protons do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 protons. Okay, I didn't read it here. So we have 8 protons, or protons, however you say it. And how many electrons do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 electrons and 8 protons. Definitely, because there are more negative than positive charges, it's going to be a negative ion. Now, A, B, and C, are they particles of the same element? Definitely, yes, they are particles of the same element. Why? Because they have the same atomic number, which is the same number of protons. Okay? Now, A and B are isotopes of the same element. Now, definitely A and B are isotopes of the same element. Why? Because first of all, they are an atom. Okay, they don't have a charge. They have the same number of protons and neutrons. The same number of protons and electrons. Okay, whereas B has a greater number of neutrons than A. So if they have the same number of protons and the same number of electrons, but a different neutron number, okay? Or in general, a different mass number, then they are definitely isotopes of the same element. Now, A is a non-metal. Why? Because it has 6 electrons on its outer shell. So 1, 2, 3, 4, 5, and 6. Meaning it's iron. Let's say it's A3. Sorry, not 3. It is 2 minus. Okay? So 2 minus means that you need to gain 2 more electrons for it to have the configuration of a noble gas. Okay? So that is why it is a non-metal, because non-metals gain negative charge, whereas they gain protons, whereas the metals, they lose electrons. Did I say protons? I'm so sorry. I mean, like, non-metals gain electrons, okay? Whereas metals lose electrons. Now in part B, use the periodic table to identify A, write its atomic symbol. So by looking at the periodic table, you will see that it is oxygen, okay, 8, and it has an atomic number of 16. Now the atomic number for particle C is very simply O2 minus, so it's same. It's oxygen, 8 protons, and then 8 neutrons, so 8 plus 8, 16 mass number, but because they have 2 extra electrons, it's going to be 2 minus. That's it. Now, an atom X has 16 electrons. What is the electronic structure or the electronic configuration of X? So you can write it 2, 8, and 6. That's pretty much it. If, however, you want to do the SPDF rule, you can do it this way. So you write S, S, then SP, SP, SDP, like the SDP, Sabas Digital Platform, SDP, SDP, and then SFDP, SFDP. Okay, so I prefer not to use this method. It's gonna take a lot of time and whatever, but I'm just gonna use it as an example. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this is gonna be like 2, 3. I think I did a mistake, sorry. So again, it's gonna be 2, 8, 6. Forget what I said. It's not 2S on the top, it's 1S, then it's SP, SP, then SDP, SDP, then SFDP, SFDP. Okay, so again, it's gonna be 1, 2, 3, 4, 5, 6, and 7, and then 2, 3, 4. We are here 5, 6, and 7. Then here it is gonna be 3, 4, 5, and 6, and here it is gonna be I believe 5, and then 5 again. So if we're gonna do the electronic configuration that has 16 electrons, remember S holds 2, P holds 6, D holds 10, and F holds 14. So first it's gonna be 1s2, so it lost, so it's gonna be 16 electrons minus 2, we are left with 14. Then 2s2, so again minus 2, we are left with 12. Then 2p6, okay, minus 6, we are left with 6. Okay, so then finally we put 3s2 minus 2, we are left with 4, and then finally 3p4. We do not put 3p6, we put 3p4. Okay, in the course practice it is wrong, so it's 3p4. Okay, so you're gonna just like do 4 minus 4, which is 0, 0, and that's pretty much it. So definitely this way it's very hard. I prefer you don't use it, just use that 2, 8, 6, and if it is bigger than 20, you can use the 2, 8, and then everything after is 18, 18, 18, etc. Okay, so that's it for this section. Thank you guys for watching. I hope you enjoyed and have a wonderful day.